So now let's actually load up Unity for the first time. And we're going to create a new project. Here's just showing projects I've already created, just tutorial projects I've gone through. And I'm going to create something called example. You can specify if it's going to be a 3D project or a 2D project. Understand that in Unity, there's really not much distinction between 3D and 2D. 2D is just a special case of 3D where our camera is an orthographic projection. It's a projection without any perspective distortion. And a few other settings are different when you start a 2D project. But if I start a 3D project and want to switch over to making it 2D, it's just a couple settings I have to change anyway. So you can just, it doesn't really matter here at the start whether you make it 3D or 2D. It's not a huge deal. We, though, are going to be starting with 3D. So we'll make a 3D project. And Unity will load up here. It takes a little time. There we go. Okay. So the first basic concept to understand about Unity is that your project contains some number of assets. What are assets? Well, they're just the data elements that are used in your game, and they come in various different kinds. There's sound assets, image assets, mesh assets, that's 3D geometry. Those kinds that I just mentioned, those are things that you create externally to Unity. You use other programs. Images, of course, you would create in a program like Photoshop or Illustrator or whatever. And sounds, of course, are various different programs for creating sounds and music. And 3D models, meshes, those are things you create in programs like Maya and Blender. Blender is probably the one you want to start with if you're going to get into 3D modeling. It's this whole very complicated thing unto itself. So we're not going to talk about that at all. We're going to, for a long time, we're just going to be sticking with very, very basic built-in meshes of cubes and spheres and cylinders and really basic stuff like that. Again, we're not going to focus on making things look good at all. We want to learn as much about Unity itself, not really about creating good art, which is a whole field unto itself. Anyway, so a lot of kinds of assets you'll create external, and you want to bring them in. And let's see, I'll just, what do I have? I have this duck. I'm going to drag that into Unity here, make an asset out of that. And now what's happened is in my project here, I can open up in Explorer, my project. And here's my project folder. And in your project folder, you have these 5 subfolders. Assets is where all your assets go. And there's the image file I just brought in. And it now has an associated meta file. Unity will generate these meta files for every asset you bring in. And what that meta file is, we can actually just open that up in a text editor. And what it looks like is, well, one thing here is that for every asset you bring in, Unity wants to have an associated ID, a unique ID for that, a GUID for it. So it just randomly generates this thing here. And then it has other information about the file. And this is describing how the asset's going to get imported. If we go back to Unity and click on the asset, you have all these options. It depends on what kind of asset we're talking about. In this case, it's an image. So there's various different ways, like you would want to have the image compressed when it's brought into your project and stuff like that. So that's all described in the meta file. And be sure not to delete the meta files. You want to keep them around, make sure they have the same name and stay in sync with these files. So, I mean, we could, it's up to us exactly how we structure stuff in our asset folder. We can just create random, we'll just call it images. And I'm going to move these into there and just be sure to move them together. And as long as you do that, Unity should be fine with it. Though, actually, I'm not sure. Maybe that will break some things because now the path to that asset has changed. I think what you really want to do, here, let me go back actually. Let me undo the move. Oh, notice that directories themselves have meta files. Yeah, actually, I think the thing to do you really want to do is to make sure that what's going to happen in your project is things in your game will reference your assets, and you don't want those references to break when the file path changes. So if you move something from one directory to another or change its name, you don't want to have those references break. That's what the GUIDs are about. So instead, if you want to rename things or move them, you should do so inside Unity. So now if I rename this to Mallard for Mallard 2, if we go look at the directory, the meta file, its name has been updated in sync, so it's no longer mallard2.jpg, it's Mallard with no number 2. If I were to move this into images here in Unity, also it's moving the meta file along with it. And I don't know if anything, I don't think anything in here changes, but yeah. Anyways, just to be safe, you should really only move and rename stuff in your assets directory. That'll prevent the references to assets from breaking. So an image is an example of an asset that we'll be importing in from an external program. But then there are some assets that you'll be creating directly inside Unity. For example, there's what's called a material. I'll just leave this with the default name, new material. And the inspector here, I select the asset here and it shows all the options about the material. What is material? Well, A mesh, as I described, it's the wireframe of a 3D object. It's just the vertices in three-dimensional space and the edges that connect them. It's not the actual texture information about how the polygons get filled in. That's what a material describes. A material is all the information about what should be drawn on the surfaces and how they should be drawn. So we can specify textures. We can draw the so-called albedo. That's the main texture you see on an image. So here, let's just set that up. I can drag this here. And okay, so now this is a material which is referencing the texture such that when you apply this material to a mesh, that texture will be drawn on the surfaces. And how the coordinates of the texture match up with the geometry, the various polygons that make up the mesh, that's something you generally arrange and match up in 3D modeling packages like Blender, as I mentioned. So there's a lot of complications to that, which we won't go into as of yet, if ever. But anyway, so we can also like just apply on the material. We can say, oh, everything here is red, so it's going to tint material to being red. You have controls over things like that. You have controls over how lights are supposed to affect these surfaces. Lots of options, and we have various rendering modes, which, again, all these details we won't get into as of yet. But that's the idea of a material. It's a little strange because you might assume naively that, oh, well, I have my meshes and I want to apply textures to them, so I just associate the texture with the mesh. But no, we create these materials, apply the materials to the meshes, and the material describes what the surfaces should look like. And there's a lot of options about how exactly we want the surfaces to get rendered. So again, a material is a kind of asset we create inside Unity. There are many other kinds which we'll get to in time. One, for example, C# script. So this just creates a file called .cs. And if I double click this, it'll open up the code in Visual Studio. You can configure that in Unity if you want to use other text editors. Understand that, yes, Visual Studio has a C# compiler. And when I edit my code and save, it'll compile my code or attempt to compile my code. And here's a compilation error, and it'll tell me there's a problem. But Unity has its own variant of the mono C#.NET runtime. So what you compile in Visual Studio is not the compiled code being used in here. So it's actually, in a sense, it'll just be compiled twice when we save here. Regardless, it's nice to have Visual Studio, just a good environment for writing C# code. And Visual Studio these days is practically free. For a long time, Unity by default would install MonoDevelop on your system, but very recently they moved over to now Visual Studio is installed by default and associated with Unity. So this is the default choice going forward. So we'll come back to how to write your code later. But anyway, so this is a kind of asset. It's a file that sits in your assets folder. It has an associated meta file, and it's something that certain elements in our game can make reference to, as we'll see. That's most everything we need to know about assets for now. We'll talk more about them later. And that's everything under the project window. The project window really probably should just be called the assets window, but they call it the project window. And then up here, what's called the hierarchy window, that's showing us all the game objects in our current scene. And by the way, if you don't have Unity looking like this and you want it to look like this is what I recommend. Come up to layout, select 2x3. It'll arrange things like this, but you can just drag this down, dock it there. That's what I prefer. And I like to have the console open. So I like to dock that down here. That's my preference. That's what I find generally most useful. But this is all customizable and it's up to you. Here it's showing my current scene. That's what this untitled thing is. And the untitled currently has two game objects in it, one called main camera, one called directional light. Those are just the default objects included in a new scene. And if I hit Control S right now, what I'm going to be saving is an asset called a scene, a .unity file. And I'm just going to call this example, because that's the name of my project. I could call it whatever I want, but now you'll see in assets in my root folder, there's an example scene. And we actually can view that in a text editor. It's just a YAML file, which is sort of an alternative to like JSON or XML. And it's just all the information in text form describing the scene and all of the game objects currently in it, which right now is just those two game objects. So there's actually not that much in it as of yet. Most typical games will have much more complicated scenes. Anyway, just understand it's really just a text file. That's how it gets saved. And what are these game objects? Well, a game object is just a logical container for what are called components. This main camera here, if I click on it, oops, the inspector's stuck. It's still showing me the new material because earlier I locked that. I'm going to unlock it. So now whatever I click on, whether an asset or a game object, it's going to show me the components of that object in the inspector. So click on the main camera, and it's a game object containing this transform component, which I can expand and collapse, this camera component I'm expanding and collapse, and then a flare layer and an audio listener. So right now it's just 4 components. And you can see the list of all the component types under here. There's many different kinds of things for lights, for physics, for particle effects, meshes, rendering stuff, just a whole bunch of stuff, which you'll learn in time. So in this particular case, the transform component, that's the one component that every single game object is going to have. If I right click here and create a new empty game object, it'll have by default the name game object, but I can rename it to whatever I want. I'll call it Fred. And Fred, by default, this new game object just has a transform component. Every game object has to have a transform component, whether it's going to use it or not. It's a little strange. The transform is the position in 3D space. It's a rotation in space and a scale. Those 9 coordinates together are the transform of an object. And everything has to have it whether it's going to be used or not. The directional light, for example, a directional light is a kind of light that casts on the scene as if from a very distant large source of light, like the sun, and all the rays of light shine down in parallel. And because of that, because it's logically a light that's in effect infinitely far away, it doesn't matter where you position the light, but it is casting rays in parallel. That's what it's kind of showing you with the icon. When I select my directional light, it's showing these yellow beams, and I can rotate the object, and that is relevant. That part of the transform actually affects the lighting of the scene. But if I translate it around, if I move it up and down, left and right, that has no bearing. So it doesn't matter where we position this thing, but it doesn't matter how we rotate it. So there are cases like that where the transform may be ignored in its entirety, or maybe only some aspects of the transform are relevant. But again, all game objects have to have a transform component. A camera component, as you might assume, makes a game object into a camera. It's something from which we can render the world. And there's nothing on our world yet except a skybox at the moment. This will be a lot clearer once we add visible objects into the scene. But here I'm moving the camera around. I can rotate it up and down. And this is relevant for the camera because where you position the camera, of course, affects what you see relative to the objects in the scene. And the flare layer, that component simply adds a flare effect to your camera. So depending upon what lights it's looking at, there are cases where you'll see a little flare. I don't know why they put that on there by default. And audio listener, that's a component which picks up sound coming from audio source components. So other objects you're going to attach audio source components to. And from those audio sources, we can play sound assets. And based on proximity, an audio listener component, which by default is attached to our camera, is going to pick that up. And generally you want to hear stuff from the perspective of the user's view. So that's why it's generally attached to the camera. Fred, we have this empty game object. Let me move the directional light out of the way. It's right up in our faces. Okay, so Fred, yeah, you can always just double click on an object to center the scene view on it. This is the scene view. This is where we move stuff around and you have this preview grid of things. Whereas the game object, this is what the game looks like from the current camera, which is by default this main camera, the only camera we have at the moment. Anyway, so Fred, we can add components to it. Let's make a visible mesh. And to make a mesh we can actually see, we need 2 components. We need what's called a mesh filter, and we need a mesh renderer. The mesh filter is where we just specify what the mesh is, and we don't have any mesh assets yet in our project, but there are these built-in meshes: cube, capsule, cylinder, plane, sphere, and quad. We'll just make a cube. And right now, our cube is rendering as just pink. That's Unity's way of making sure that a mesh stands out. If it doesn't have an associated material, you want to catch those mistakes so that you can fix them. So that's why it's bright pink, or magenta, I guess you would say. So we can apply though a material to it, and we have a material here, our duck material, which I've shaded red. Let's get rid of that red tint so it looks like a duck. And we want to just associate that onto the mesh renderer component of Fred. And we can just do so by dragging here. Or I could have done the same thing, I think, by dragging to I think that also would work. Or if you look at the components under materials, in some cases a mesh actually might have multiple materials applied to it. This is an array component. That's why it expands and collapses like this, and you can specify a size. So we can have like 3, and then we can apply 3 materials. I don't think it would actually do anything if we applied 3 different materials, because the way the mesh is, its geometry is defined. there's only one material it's expecting, so I think the other two would be ignored. Anyway, let's just set that back to 1, so it has one material. And this is where we can also apply the material. We can come here, select from materials here. Like there's this default diffuse material, which just makes something white. But let's go back to the duck, and we can directly drag from assets to here. So that's another way of applying the material to the mesh. Just be clear here, we have two components on our Fred game object. The mesh filter, which specifies the mesh renderer, which specifies various options about how lighting should affect the mesh. We'll just go with the defaults for now. And also it's where we specify what materials are being rendered on the mesh. So why are these separate components, you may be asking? Why not just have one component, which is both the renderer and the filter? Well, there are actually cases where maybe you don't necessarily want to have a mesh be rendered. You don't want to have it visible, but you want to use its geometry to define, like, say, a collision box or something like that. So you might have a mesh filter without a mesh render. I don't think it ever makes sense to mesh render without a mesh filter. I don't know. I think you might even get an error if you delete this. Let me see what happens. Remove component. And I'm going to try and play the scene. Is it going to accept that? Well, we don't get any errors, but we definitely don't get anything rendered. So let's just undo that. Put the mesh filter back. Okay, and now if we render the scene, okay, then you see, there it is. This is actually the game being played, and it looks just the same as when we didn't play it, but that's just because we have a totally static game that doesn't do anything as of yet. It's just rendering from the camera and nothing else is happening. Let's move that camera around so we can see it in action. We'll move it closer to our duck. Move it down. Something like that. That's good enough. Whatever. Okay. So that's a basic example of a game object. Again, a game object is really just a logical container for some number of components, and it's the components that really define what kind of game object that is. There are some cases where a component you can only have one instance on a particular game object. Like, I don't think you can give a game object multiple mesh renderers, I believe. Let me try that. Yeah, we get an error message if we try and add a second mesh renderer to this object because it already has one. There are cases where if you have one kind of component, you can't have a different kind of component. Like I think under tile map. Can I add a tile map render? No. Yeah, because we have a mesh render. You can't also have a tile map render. That just doesn't make sense. There's a conflict. There are certain cases where if you add a component, other components are also required. And generally, if you try and add one of those components, it'll automatically add in the other required components. So there are some various rules like that. It just depends on what kind of components we're talking about. But there are cases where you can add seemingly unrelated components to the same game object because maybe you just want them to logically be grouped together, or you want them to share the same transform. That's one reason to group otherwise unrelated components onto the same game object. Sometimes that's useful. But again, game object, just sort of a generic container, and we can call them whatever we want. That's totally arbitrary. In fact, I can very quickly duplicate my object here in the hierarchy if I just hit Control D. And by default, it'll give it the same name, but with a number after it to distinguish. But actually, I can give two or more objects the same name, and that doesn't necessarily harm anything. Though in our code, as you'll see, there's a way of finding objects by name. And if you have multiple objects with the same name, it's indeterminate which one you retrieve. So generally, you probably want to give things unique names, but you don't have to. I'll just get rid of this second Fred. There we go. Now, for our purposes, we're probably going to be creating a lot of simple game objects like this. So rather than having to create an empty game object and then add the relevant components so we can see like a cube or a sphere, as a convenience under game object here, we can just simply come 3D object and there's a cube. And it automatically adds in the cube, mesh filter, and a mesh render using the default material at the start. So it just looks white, but we can quickly change that with whatever material we want. I'm going to undo that and keep it white. It also adds this box collider. We'll talk much more about colliders later, but understand for now that what a game object looks like doesn't necessarily correspond to how it collides with other things. By default, the objects that you render don't collide with anything else at all. They'll just pass right through and render on top of each other. If you want to detect when things collide, that's where colliders come in, and then we'll talk about that when we talk about physics. So we're not going to do things with collisions at the moment, so I'm just going to actually remove this component. But it's actually kind of harmless right now, so it doesn't really matter. Let me also get a sphere in here. Okay, I don't want to move that over. Actually, what I'm going to do is I'm going to reset this component. I'm going to reset it, and it just has the default values. So it's going to reset back to the origin. You can, if I modify this stuff, the rotation, the position, you can reset the position and rotation independently. But I'm just going to reset the whole thing so it's back at the origin as we see down there. And we'll do the same for the cube, so they'll be overlapping each other. Just reset the whole thing. Center on that in the view by double clicking. And let's make the sphere bigger so that it pokes out, so we can see it poking out of the cube. There we go. Okay, and to make that stand out clear, I'm going to create another material where, well, I could just use the duck material and apply that to the sphere. Okay, now you can see what's going on, I think. And if we just pan down here, you can see it's like poking out through this cube. Anyway, so you can just see there's two distinct objects there. Oh, and one small thing I want to make clear here in the inspector view is showing us all the components of this object, and it sort of visually implies that the material here is a component, but it's not a component. It's an asset, and it's being referenced by the mesh renderer, but as a convenience, the inspector is showing you all the materials being referenced by the components of this object. And it's just a convenience, so you can come down here and look at the materials being applied to this object and perhaps mess with these values if you so choose. But this is really just an asset being referenced by one of the components.